In this video, we will learn how to write the equation of a line in both point-slope form and slope-intercept form. To begin, when we start writing the equation of a line, we are always going to start, so we always start in what is called point-slope form. And in order to write an equation in point-slope form, we need two pieces of information, and they're right inside of the name. We need a point, and we need a slope. So in order to write an equation of a line in point-slope form, we need both a point and a slope. Now the other thing I want you to look at here is this is the equation of point-slope form in general. So when we get a point and a slope, what we're going to do is we're going to put those two pieces of information into this equation here. Now you're probably wondering where these pieces of information go. Well, if I can go back just a little bit, there we go. I'm going to label them. So first, M. M is a letter in mathematics that often represents slope. So if you know the slope of your line, you're going to take that value and you're going to substitute it in here for that M value. So slope goes in for M. Then from here you see Y1 and X1. This means the Y value of the point that you know. And this one represents the X value of the point that we know. So if we have a point and a slope, all we're going to do is write Y minus whatever our Y value of our point is. So whatever that value is going to go there, is equal to our slope of M, which is right here. Then in parentheses, X minus our X coordinate of our point in parentheses. So we're going to be substituting in three different values when writing an equation in point-slope form. Now that we know what point-slope form is, we need to take a look at slope-intercept form. And you should remember from algebra that slope-intercept form is represented by y equals mx plus b. So a couple of things to highlight in this equation is that the y is alone. So we always have y by itself in y equals form. And then our m value here represents our slope, and our y value here represents our y-intercept of our line. So those are the key pieces of information in slope-intercept form. Now, we're going to write equations into slope-intercept form by starting in point-slope form, and then we're going to essentially use our knowledge of basic algebra to rewrite that equation into slope-intercept form. So looking at the second example here, the instructions say to write an equation in point-slope form and slope-intercept form for the following situation. So what we're going to do is we're going to always start in point-slope form. That's what our first goal is going to be. And then we're going to rewrite that equation into slope-intercept form second. So we'll label that as we go. So we can see from the information we have here that we have a slope and we have a point. So this is a perfect situation to use point-slope form in. So remember, point-slope form is y minus your y coordinate is equal to your slope times x minus your x coordinate in parentheses. So let's go ahead and take our situation and write it into point-slope form. So we have y minus our y coordinate here of 4 is equal to our slope of 1/2 times x minus our x coordinate here of -3. And there is our point-slope form. Now we should practice cleaning this up a little bit, utilizing keep, change, change to get rid of double negatives. So here we have y minus 4 is equal to 1/2 x plus 3. So this is our point-slope form. Now, in order to get slope-intercept form, all we need to do is rewrite this. So remember, our goal in slope-intercept form is we need to get y alone, and we need to have no parentheses in the problem. So we're just going to use two algebra concepts in order to help us do this. The first thing we're going to do is we're going to get rid of those parentheses by distributing. So we distribute that 1/2 and we get y minus 4 is equal to 1/2 x plus, you can either write 3 over 2, because that's what 1/2 times 3 is, or if you use a calculator, you will also get 1.5. So either one of those answers is fine, but you need to be able to distribute that fraction. Then from here, we're going to add 4 to each side to get the y alone. So we have y is equal to 1/2 x plus 5.5. So we can see here that we have our slope-intercept form where y is alone. So you can see that y is alone, and we have y equals mx plus b. So this next situation is a little bit different because it's a graph, but it's also very similar because we can see that we know 2 points that are clearly on our line. So we're going to start by looking at point-slope form, and remember for point-slope form, we need to find our slope first. So you can find your slope either using the graph or the equation. So if you use the equation, you're going to do y2 minus y1 over x2 minus x1, and you can use that if you would like. The other thing you can do is you can just look at the graph. Remember, slope is also rise over run. So if we start here at point 1 and we travel down here to point 2, we're going to go down 3 and to the right a positive 2. So our slope, whether we use the equation or the graph, is going to be a negative 3 over 2. So from here, we're going to look at point-slope form. We need to pick a point, and it doesn't matter which point you pick. You can pick whatever you would like. So I'm going to pick this first point right here. So we're going to write an equation into point-slope form, and remember that's y minus your y coordinate, which is 3, is equal to your slope of negative 3 over 2, times, in parentheses, x minus your x coordinate of 2. So this right here is your point-slope form. Then from here, we need to rewrite this into slope-intercept form. In order to do that, we're going to distribute. So here, I'm going to utilize some keep, change, change, just so I don't make a sign error. So I'm going to do y minus 3 is equal to negative 3 halves x, and then I'm going to use keep, change, change here, so I can see I have plus negative 3 over 2 times negative 2 over 1. So if I multiply that out, I get y minus 3 is equal to negative 3 over 2x plus, this becomes, negative times a negative is a positive, 3 times 2 is 6 over 2, which becomes a positive 3. And then in order to be in slope-intercept form, I know that y needs to be alone, so I add 3 to each side. So y is equal to negative 3 over 2x plus 6. So now we have both point-slope form and slope-intercept form. And final example here. So this one might look a little weird, but this is known as function notation. And what this is saying is it's saying that when x is equal to 3, y is equal to 5. When x is equal to negative 2, y is equal to negative 5. So what we really have here are the points 3, 5, and the points negative 2, negative 5. So let's start writing this in point-slope form, and to do so we need to find our slope. So we'll calculate that using our y2 minus y1 over x2 minus x1 equation. So we have some points that we can label. So we have x of point 1, y of point 1, x of point 2, y of point 2. So as a result here we have negative 5 minus 5 more over negative 2 minus 3 more. So here we get negative 10 over negative 5, which that simplifies. Negative over negative is a positive. That simplifies to 2. So our slope here is 2. So then we're going to move forward and write this into point-slope form. So all we need to do is pick a point. I'm going to pick this point to start just because it has some positive values, and those tend to be a little bit easier to work with. So point-slope form, we do y minus our y coordinate of 5 is equal to our slope of 2 times, in parentheses, x minus our x coordinate of 3. So here we have our point-slope form. And then from here we need to find slope-intercept form. So if I distribute, I have y minus 5 is equal to 2x minus 6 add 5 to each side, and we have y is equal to 2x minus 1. So we have both point slope and slope intercept form.